E EPA 608 Technician Certification Study Guide Core. Ozone. Ozone depletion. Ozone is a naturally occurring gas molecule that is made up of 3 oxygen atoms. This gas occurs both in the Earth's upper atmosphere and at the ground level. At ground level, ozone is considered bad and is a pollutant that causes significant health risks as well as damages vegetation. The ozone that occurs in the upper atmosphere or stratosphere is considered good ozone. This good ozone in the stratosphere is a layer that extends from about 6 to 30 miles above the Earth, creates a protective shield for the Earth from the sun's harmful rays, the ultraviolet light. Depletion of the ozone allows more of the sun's harmful UV rays to reach the Earth, resulting in increased temperatures of the Earth, increased cases of skin cancer, increased numbers of cataracts in people's eyes, increased ground level ozone, crop and vegetation loss, and reduced marine life. While the amount of ozone in the stratosphere varies by location, time, and season, the effect of the ozone depletion is a global problem. Destruction process of ozone. Ozone can be destroyed by chlorine and bromine atoms emitted into the atmosphere. When a chlorine atom meets with an ozone molecule, it makes an oxygen atom from the ozone molecule. The ozone molecule, O3, changes to an oxygen molecule, O2, while the chlorine atom changes to a compound called chlorine monoxide, CiO. When chlorine monoxide meets ozone, it releases its oxygen atom and forms 2 O2 oxygen molecules, leaving the chlorine molecule free to attack another ozone molecule and repeat the process. It is estimated that a single chlorine atom can destroy 100,000 ozone molecules. It was known that the oceanic and terrestrial ecosystems naturally emit chlorine and bromine, but it wasn't until the mid-1970s that it was discovered that humans-produced chemicals were being emitted into the air and quickly destroying ozone. These gases come primarily from CFCs, chlorofluorocarbons, and HCFCs, hydrochlorofluorocarbons, which were once used in almost every refrigeration and air conditioning unit manufactured. A CFC is an organic compound containing chlorine, fluorine, and carbon. A HCFC contains hydrogen, chlorine, fluorine, and carbon. Despite being heavier than air, CFCs reach the stratosphere through wind motion that carry them upward. Because CFCs will not dissolve in water or break down into compounds that dissolve in water, CFCs remain in the atmosphere and do not rain out easily, allowing them to reach the stratosphere over time. When the CFCs and the HCFCs reach the atmosphere, they are broken apart, release their chlorine atoms, and start the process of attacking the ozone molecules. Proof that CFCs have reached the stratosphere come from air samples taken in the stratosphere. Determining whether the chlorine emissions was from naturally occurring instances like volcanoes or refrigerants is to be debated. But scientists' studies have shown that over 80% of the chlorine in the atmosphere is from human-made gases. Supporting studies revealed the following. The rise in the amount of chlorine measured in the stratosphere over the past 2 decades matches the rise in the amount of fluorine, which has differential natural sources that chlorine over the same period. The rise in the amount of chlorine measured in the stratosphere over the past 2 decades matches the rise in CFC emissions over the same period. Samples of air taken from the stratosphere over the erupting volcanoes shows that volcanoes contribute a small quantity of chlorine to the stratosphere compared to CFCs. Despite the efforts of making refrigerants more environmentally friendly, with past emphasis being solely on ozone depletion, there is more and more scientific evidence supporting how the effects of refrigerants contribute to global warming. Evaluation has now been diverted to both older refrigerants and creating new refrigerants, with emphasis on both ozone depletion potential, ODP, and global warming potential, GWP. Ozone depleting potential, ODP, is the measurement of the ability of the CFCs and HCFCs to destroy the ozone. CFCs have the highest ODP, followed by HCFCs. HFCs do not contain any chlorine and therefore do not have an ODP, global warming potential. GWP is a relative measure of how much heat greenhouse gas traps in the atmosphere. It compares the amount of heat trapped by a certain mass of the gas in question to the amount of heat trapped by a similar mass of carbon dioxide. GWP is expressed as a factor of carbon dioxide, with carbon dioxide being 1. Hydrofluorofins, HFOs, also known as alkanists, are composed of hydrogen, fluorine, and carbon. Although CFCs and HFCs also contain hydrogen, fluorine, and carbon, HFOs contain at least one double carbon bond, making it a more stable compound. This characteristic allows for HFOs to have the benefit of having both a zero ODP and a low HWP. Note: silicone seals and gaskets are not compatible with HFO refrigerants. Clean Air Act and Montreal Protocol. Clean Air Act. The United States Environmental Protection Agency, the EPA, regulates the criteria of the 1990 Clean Air Act, CAA, which includes Section 608, Refrigerant Recycling and Emissions Reduction Regulations. The purpose of the CAA is to limit how much of a pollutant can be let into the air anywhere in the U.S. Section 608 of the CAA focuses on capturing and ultimately eliminating the use of chlorofluorocarbons. In particular, the CAA calls for the following to limit chlorofluorocarbons damage to the atmosphere. Phase out. Set dates to phase out CFCs and HCFCs. For example, phase out date to produce and import HCFC R22 is January 1st, 2020. Prohibit venting. Prohibit venting of CFC and HCFC refrigerants and their substitutes. Disposal requirements. Set standards for recovery of refrigerant prior to appliance disposal. While the CAA is a federal law, the states do most of the work to carry out the program and create their own laws to comply with the CAA. State laws must comply with the CAA and, in some cases, are even stricter than the CAA laws. Under the EPA regulations 40 CFR Part 82, Subpart F, Section 608, only EPA certified technicians can purchase ozone depleting substances, ODS, used as refrigerants. As of January 1st, 2018, this includes and substitutes for ODS, including HFCs. Examples are R12, R22, R32, R134A, R1234YF, but not R290, R600A, R718, or R744. To aid in refrigerant substitution, the EPA implemented the Significant New Alternatives Policy (SNAP) program. Distributors of HCFC and HFC refrigerants must verify that their customers, specifically the individuals doing the purchasing and or handling, are up to date with their EPA 608 certifications. If the technician loses their 608 certification card, he or she must request a replacement from their certifying organization. It is required under the CAA to maintain records. The technician must record the type of refrigerant that was transferred or recovered, record the quantity of refrigerant that was transferred or recovered, keep a copy of their proof of certification at their place of business. Punishment for violating the CAA. Technicians and companies they work for who violate the CAA face harsh penalties, including up to $27,500 a day per violation, losing one certification to handle refrigerants, appearing in U.S. federal court for charges. The EPA may ask technicians to demonstrate their ability to properly perform refrigerant recovery and recycling procedures. Those failing to demonstrate may lose their certifications. An award up to $10,000 is offered by the EPA to those individuals who supply information leading to penalty against technicians that intentionally vent. Montreal Protocol. The Montreal Protocol on substances that deplete the ozone layer, commonly known as the Montreal Protocol, is a treaty among nations designed to protect the stratospheric ozone layer. The treaty was originally signed in 1987 and substantially amended in 1990 and 1992. The Montreal Protocol stipulates that the production and consumption of the compounds that deplete the ozone in the atmosphere, namely chlorofluorocarbons, CFCs, halons, carbon tetrachloride, and menthol chloroform, were phased out by 2005 for menthol chloroform. The Montreal Protocol, in conjunction with the Clean Air Act, categorizes ozone depletion substances, ODS, into two groups: Class 1 ODS, such as chlorofluorocarbons, CFCs, and Class 2 ODS, such as hydrochlorofluorocarbons, HCFCs. The Clean Air Act and Montreal Protocol review questions. CAC phases out CFCs and HCFCs. CFCs were phased out on December 31st, 1995. These refrigerants can no longer be manufactured or imported in the United States. Since the phase out, CFC refrigerants for equipment servicing comes from recovery and recycling. Retrofitting or converting a unit for use of better, more environmentally friendly is a major maintenance item that requires the EPA 608 certification.